In this video today, we're going to be learning about sulfur burners. Sulfur burner is basically creates SO2 gas, which is sulfur dioxide. And we're going to talk about some of the benefits of the SO2 burner. We're going to talk about how, how it works physically. We're going to show you the components of it. And we're also going to start one up and shut one down. These particular units have been used in California for decades. They've been around for quite a while. They're becoming increasingly popular for lots of agricultural uses. Let's start by looking at the diagram of the sulfur burner. You can find this in chapter 5 of the book that's provided down below in the description. First, you fill up the sulfur hopper, and so you end up with several 100 pounds of sulfur here in this chamber, and then from there it will gravity feed into the burn chamber. Once it's in the burn chamber, you ignite it and air is sucked in through the air intake. And as the sulfur burns, it turns into a gas. This gas is known as SO2. From there, the gas will get sucked essentially towards the aspirator, which is the location where the water is flowing from a pressurized source. And if you don't have a pressurized source, you can install a pump that will create the pressure needed. As the water enters into the pipe that goes down into the mixing tank down there, you will notice that the water's falling. It's creating a draft. That draft sucks the SO2 gas into the pipe, mixing with the water. The H2O and the SO2 create H2SO3, which is sulfurous acid. So inside of the mixing tank, you have sulfurous acid. Some of that SO2 may not have completely been mixed with water, and so some additional water goes into the secondary scrubbing tank or chamber, and the SO2 that maybe did not turn into sulfurous acid will try to escape through the scrubbing chamber, and additional water will mix with that tank, with that SO2 in that tank and cause it to fall out into that mixing tank down below as sulfurous acid. And then out the top is the vent. Once the water's in the mixing tank and it's sulfurous acid, which is just a weak acid, you now need to either pump it back into the irrigation line, so you may need a variable frequency drive pump, or you could gravity feed it into a reservoir. Now that we've seen the sulfur burner on the diagram, let's look at each of the components here in person. The first part of the sulfur burner is the part where you put the sulfur in. It's called a sulfur tank, or the sulfur hopper, and that's this big silver stainless steel piece. So now we have some sulfur in our sulfur hopper. That sulfur hopper will gravity feed down through this piece right here into the burn chamber. It's kind of like a chicken feeder, if you can think of it that way. Once the sulfur's into the burn chamber, this is where we will now start to burn the sulfur. This cap here allows us to light the sulfur. This cap over here allows air into the sulfur chamber in order to keep it burning. You'll notice on this box here that there's kind of this weld here. That means the air has to go down and back up and into the sulfur tank. If for some reason we had a problem with this particular tank and the sulfur started to build up in there, the sulfur got into this box, it would choke off the air supply, preventing it from continuing to burn. Once the sulfur is burned, it will now start to go up this flue here as it goes up as a gas. So remember, looking at the diagram, we have to have a water supply to create the vacuum to suck the SO2 gas from the burn chamber. So this green hose that you're seeing here is actually pressurized water that we're using to create that vacuum. If you didn't have pressurized water at your source, you could use a booster pump, which would be located down on the frame down here, to create the pressure that would be required to pump the water through the aspirator, creating that vacuum. So our pressurized water comes in here, and you need to have so much pressure on the gauge there for this to work properly. Every unit's a little bit different, but so you'll notice your pressurized water is coming in here. A percentage of your pressurized water will go through this aspirator and drop down this pipe, and a percentage of that pressurized water will pass through here and go into the secondary scrubbing chamber. Okay, and so as the water comes down here, that water will fall down into this tank down below. When that water falls down into that scrubbing tank or that mixing tank, that creates the vacuum on this SO2 pipe here from the burn chamber. So sometimes you want to adjust the burn rate on these, so that way they'll match the flow differences that you have in a pipeline. So in that case, you might have a box that's mounted to this that will monitor what the pH is in the irrigation system, and then adjust the burn rate. The way the burn rate works is you send more water down through that aspirator, which creates more vacuum, which sucks more SO2 gas through. The more SO2 gas you get sucking through, the more air intake you have, therefore the more burn rate you have. And so you can automate these systems as well to start and stop, and also to maintain a certain pH in the irrigation system by maintaining or by adjusting the burn rate. You also notice a couple tubes here and one there. Those two tubes bring water down to the bottom of the burn chamber, and water will flow through the bottom of that burn chamber, keeping that bottom cooler, so that way as the sulfur is burning, it doesn't just melt a hole in the bottom of the burn chamber. So we take some of that pressurized water and we run it through the bottom, and then it goes back up and then into the scrubbing chamber. So here's our scrubbing tank. This is where the water and the SO2 mix together to create sulfuric acid. As that acid is being mixed, sometimes some of the SO2 didn't go into the water, and so we end up with this gas trying to leave from this tank, and it goes up this chimney here. This is actually called the secondary scrub chamber, and so we have our water coming through the black hose there and cascading its way down through a bunch of PVC pieces as it goes down into the scrub tank. So the SO2 is trying to move up that chamber, the water's moving down. It will completely remove all of the SO2 gas. So now that we have our sulfuric acid in our tank, that sulfuric acid can be used to treat the irrigation system or a reservoir. In our cases, it's treating a reservoir through this PVC line here as it goes out to the reservoir. All right, you'll notice also on this tank here, we have a overflow pipe, this white PVC pipe here. What we don't want is if for some reason the outlet was to plug up, we don't want this thing to build up with acid and then spill into the burn chamber. So the water or the acid would actually spill out of that overflow. This is also a location where we can test what the pH is in this scrub tank down here, and it should be somewhere around 2 for this particular unit. I've got a digital pH meter, and we're just going to test what the pH is of this water here. So we're just going to stick this in, and so it looks like right now it's down to about 2.2, which is about where it's supposed to be. We've got bags of sulfur here. This is sulfur is 99.9%. We don't want any impurities in the sulfur. Otherwise, when it burns in the burn chamber, it leaves behind residue, and that's a problem. You'll notice also that this is certified organic, so sulfur burners can be used on organic farms. Here's the close-up of the sulfur prills. You know, you can see basically just little pelletized sulfur, essentially 100% sulfur. Sulfur is always yellow. So one of the things that you need to make sure that you do is you go ahead and you grab your bag of sulfur. And it's a good idea to load up the sulfur into the hopper every day. What this allows you to do is you'll know the burn rate, or you know, every day that you'll have, say, you'll burn 3 bags of sulfur, and if one day all of a sudden you only burn 1 bag, and you're used to burning 3 bags a day, you maybe know that you have an issue with your machine. So it's always wise, basically at the same time every day, to go ahead and load up your sulfur chamber. All right, so we're going to go ahead and remove the cap for the burn chamber and the cap for the air intake. All right, we got our water flowing here. So we've got some air movement through. We've got a little butane torch here. And so now the idea is you just stick this down in there. We have some residual sulfur that's down in there. And so now you just hold this here for a few minutes, maybe not that long, 30 seconds or so. All right, so we got the flame going. Now we're going to just put that cap back on. You leave the other cap off because the other cap actually blocks off the air inlet, and that will kill it. It'll stop the sulfur burner from running. So you want to make sure you leave the air one open. Basically, the acid water that's being made from the machine is now coming into the reservoir. So when you shut off the unit, the first thing you want to do is you actually want to shut off the sulfur burner about 5 minutes before you shut off the irrigation water, because you don't want any of your sulfurous acid going out to the field. Then the next thing you do here is you shut off the valve, or in our case, you shut off the water supply to the sulfur burner. You'll notice that there's no water coming up, or excuse me, no steam coming up out of the tank anymore, and then you just put the cap over the air intake. And when you put the cap over the air intake, it chokes off the rest of the oxygen, preventing it from burning. So you know, it's still hot, but eventually it's going to cool off and it'll be out. So after completely exhausting the burn chamber, it's not burning anymore. The next thing you want to do is the tank, it's called a scrub tank down there at the bottom. You want to turn the water back on to get all of the acidic water out of the scrub tank. And then you're supposed to push over that pipe, the PVC pipe there, to prevent, you know, in case there's any extra water in there, you want to get rid of it to drain the scrub tank. Now that we know how a sulfur burner works and the components of a sulfur burner, let's talk about some of the benefits of using a sulfur burner, specifically for agriculture. The sulfurous acid, again, helps lower the pH, and lowering the pH breaks up carbonates and bicarbonates, which also can can buffer the pH of the soil and improve the soil intake rates as well. In addition, it's good at disinfecting irrigation lines by killing iron bacteria and algae. This is why you'll often see sulfur burners next to reservoirs as they treat the water that will eventually be used for irrigation. Another use for these is for apples. Often they'll use water to cool the apples so that way the sun doesn't cause sunburn, and you'll see water spots though if the water has any carbonates, precipitate. So you'll break up the calcium carbonate with the sulfur burner so that way there's no water spots left behind on the apples. Hopefully this answered some questions for you about sulfur burners, and we have other videos in the fertigation series that you're welcome to check out. Thanks for watching.